Well, hello, everybody. Good morning, good afternoon, good evening, good night, wherever you are, somewhere in our absolutely lovely world. Thanks so much for joining us here live today for the one and only Serverless Office Hours. We're streaming on the AWS Twitch channel and also on YouTube on AWS Events channel. So wherever you are joining us, you are absolutely more than welcome. Now, do we have a live stream for you? We often don't give away lots of money, but Eric Johnson has reached deep into his pocket. And he's very happy that we're going to be talking about all the AWS Lambda Hackathon today. So welcome. We have a whole bunch of judges today, and we're going to be talking about the judging process, what we thought, and some of the... And obviously, we're going to do the big reveal for some of the winners. But please remember, we are live, so send us your questions, send us your comments. Tell us if you were part of the hackathon and what you enjoyed building and how it was for you. Tell us where you're from. We love hearing how we have our sort of global serverless audience. Of course, Daryl's getting straight into the point. Show me the money. We'll get some money. This isn't an infomercial, but there'll be a slow reveal. Otherwise, it will be all over very quickly.
Yeah, we got to drag it out. We can't just, we can't. Here they are. Have a good day. We'll see you later. Come on. We have to have some power control here. Exactly.
So this stream could have been an email, right?
Eric's got an hour and he's determined to use it.
Yeah, exactly. Sully's out there saying he's excited to see what's going on there about who won. I will tell you, I'm going to throw this out there. We're going to say this again later, but I was pretty wowed by a lot of the submissions. There was some, I was looking like, whoa, this is better than probably what I would have built. And I've been doing serverless for a long time. So super cool.
Cool. Awesome. We've got a bunch of judges. So in random order, Rajesh, welcome back to Serverless Office Hours. For people who don't know you, can you let us know what you do at AWS?
Hey, hi folks. I'm Rajesh. I'm a principal engineer at AWS Lambda, and I do things, some things here and there about engineering stuff and building Lambda.
That's the technical title.
I do things here.
Here and there.
Is that your performance review at the end of the year? I do things.
I'm a principal thing doer.
Excellent.
Nice.
And also, Janek, welcome back to Serverless Office Hours. Janek joined us on our sort of 10-year anniversary episode we were talking earlier. So yeah, Janek, welcome back. For people who don't know you, who is Janek and what do you do at AWS?
Hey everyone, I'm Janak. I lead the Lambda team's product management discipline. It's really great to be here today. We've been really humbled by the amount and the diversity of the ideas and the submissions that you've done in this hackathon, and it's exciting to be able to talk about some of them today.
Cool, excellent.
Janik, I have to ask you a question. There's a lot of writing on the boards behind you. Are there any secrets behind you?
No.
Okay, all right.
It's just how awesome serverless is. That's not a secret.
Because I don't want to call attention to them, but I'm just throwing that out there. So.
It's a bunch of I love Lambda graffiti.
There you go.
Excellent. And Gunnar, welcome back. How are you? And for people who must probably know Gunnar, but if you don't, from the lovely land of Sweden, tell us, what do you do at AWS?
Well, thank you for having me back. So I am a developer advocate with AWS. So I'm fortunate enough to get to spend my days just meeting, talking to developers all around. So I'm really enjoying life, I have to say.
Awesome.
It's been super fun with the hackathon.
It has been. Awesome, and I can't wait to talk about it. But of course, we've got Addy. Addy, welcome to Serverless Office Hours. Your sort of first time. You've been an instrumental judge as part of this. So great. Tell us what do you do help at AWS?
Yeah, it is great to be here. I joined the Steam's judging group as in my role as a principal designer across serverless and also CX. So I look at all parts of AWS, and I've spent some of my time here as a manager across what I called core services. So it was really awesome to see people using all sorts of combinations of services, like lots of S3. It was interesting to see all of the work that was done with some of AWS's newer services around image detection, AI/ML models, etc. It was really cool to see all of those things come together. And so I was looking at this from a user experience angle was sort of my vantage point for looking at all of these awesome submissions.
Cool. And what's so nice to have Addy as the judge and also as part of the sort of serverless team is, we've got Rajesh, who's, hardcore engineer. We've got Janak from the product side. Gunnar and Eric and I are, developer advocates, so podcast to the side. But Addy being involved in developer experience and user experience and design, that's very intentional that, Lambda specifically is putting a lot of work into that to make sure it's all easier to use for developers. So, Addy's spearheading a whole bunch of that stuff. So it's cool to have, another aspect that some people externally don't often see. Should we have just Eric? Should we just talk about what the hackathon was for people who haven't been joining us and don't know what it's about? The AWS Lambda Hackathon. So obviously it was all about prizes. So what were the prizes, Eric?
So this is a lot of fun. There were several prizes. Obviously, we did. First prize, $6,000 US dollars. This should be clear. These aren't, it's not something come in at the last minute and change it to something else. But these are US dollars, and $4,000 for second place, $3,000 for third place, and then we have four teams or individuals that honorable mention at $500 each. And it was really interesting. I don't know if the other judges, and by the way, these aren't all the judges. There was actually probably another 5 or 6 or 7 involved in this. Just not everybody's. They're out building the product still, so they're not able to be here. But it was interesting how many of them. We had submissions from all over the world. Not just U.S. Not just. There's a lot from India. We had quite a few from several countries in Africa. We had Europe. We had LATAM. It was a lot of representation. That was really cool. But of course, the prize money will be USD. So there you go.
Yeah, absolutely. And we can see even as the comments coming in after Sally was talking about who's excited. But we've got people from the UK. Thanks, Ian, for joining us. Zero Agents. Hello from Miami. Good friend Peter Smith from New Zealand. We've got Alejandro from Colorado, I presume. Leandro joining us from Portugal. Leandro also helped with some of the verification. Alejo from Colombia, from Ireland, and these are the people who are just doing stuff in the chat. So there we can show our sort of global impact of what serverless looks like. But what is the mission? Rajesh, do you want to just take us through? What were we looking for what people needed to build?
We had 3 criteria which we were looking for, basically everything around Lambda and how do you use Lambda for your day-to-day applications. What is the can you solve a real world problem using Lambda a serverless technology and all the toolings that is available around this. And we were expecting them to at least use one Lambda function and all the ecosystem around it, the step function, SQS and S3 and all these things. But we were so amazed. I was so amazed. It was so hard to pick the winners. And the criteria was one, and suddenly I realized people were so innovative. They use 5 to 10 lambdas, 15 lambdas. Some use 15 lambdas and how they choreographed. And the third criteria was around using the services around it, how the integration works. You can use S3, DynamoDB, Bedrock, and step functions, event bridge. So people use all those innovative ways of combining these things to achieve a common business problem, a goal to solve a business problem.
One of the things that was interesting, I think, in our conversations, because as I was just saying, there's the quality of the idea, the architecture, design, and the completeness. And it was interesting to talk about each of these points because many different projects were really good at different things. And I think some of the most interesting part of this discussion was around the quality of the idea. The architecture of it is a little bit less. It was interesting to see how people approach different challenges. I think that stuck out to me around that first category was projects where the problem was really well defined and then the solution. And so specific challenges where you could really see how an entrant had taken an approach that dealt with that specific problem and looked at it maybe from a couple different angles. It didn't just sort of try to do a really broad piece, but it looked at a specific challenge and then maybe showed one user, but then other views that solve different aspects of the problem. And that kind of bled between maybe completeness and quality. But I thought those were really cool iterations to see where people kind of had dug in and been exceptionally thoughtful about how you might approach a problem, be it common software challenge or a healthcare issue or something totally different.
Yeah, no, thanks, Andy. Yeah, you can. I mean, these were the three criteria we have. Quality, creativity, architecture, and completeness. And they are particularly vague requirements because we wanted to see the creativity from everybody. Yeah, and as Adi said, there were different sort of scales from each one of these kind of things, and it was interesting to see also between the judges how judges would also sometimes disagree or have different opinions on kind of things, which is nice to have a diversity of judging. And just to go back because I did flip the slide quickly, but just to let you know what. We won't reveal yet. We won't reveal yet. That was close, wasn't it? But yeah, people needed to provide a public code repo, a detailed README, and a sort of 3-ish minute video seeing it in all in action. We did have some submissions who didn't have some of these things. So that's why, if you are desperately wondering why you maybe didn't win, some of the submission requirements may not have been covered. But yeah, Eric, just take us through some numbers. I mean, how many people were involved in this hackathon, and what was the judge's job?
So we were looking at, when we originally started doing this, we were thinking, maybe 1,500 people would, participate and maybe several hundred would do submissions. We had 3,600 participants. It was like, whoa, or over 3,600, right around there. And then we had over 300 submissions. Quite a bit over, but some of them we maybe didn't meet all the criteria when we pulled those out. But 300 qualified submissions that went in, and then we broke it down to the top 8. But there were some real fine lines between a lot of these. I know we wrestled back and forth on some of these. I know at one point Addie and I were arm wrestling over who should actually, who's first and not she won, but whatever. But I mean, it was just crazy, how fine these were, and you really started getting in deep and thinking about did it, real world problems, things like that. But that's the numbers.
Excellent. Well, good. For submissions that came through to all the final judging rounds, like what are the things that people did right, or what were the things that made them succeed in the hackathon?
So I think what I saw pretty much across the board was that people were using well-established patterns. They used architectural best practices, and I think that goes to show how much serverless has evolved over the years, so people can just use these patterns that are out there that we have at serverlessland.com, for instance. But so what really set things apart were, just like Adi talked about, with the creativity, the ideas that people had, the type of problems that they tried to solve using those best practices. So I think a lot of it came down to that. And we talked a lot about the videos. Obviously, that gave us a glimpse of what the things were. So we were able to look at those videos, but then it was just about diving into the repos, looking at the solution, what they've actually built, and how they were trying to solve those issues.
Definitely. So Rajesh, you also reviewed some of them. What is your process? What were you looking for? I mean, did you watch videos, deploy the kind of things? What is your thought process as you were going through from the sort of architecture side, the design side, and then the completeness of it?
Yeah, and I think we all followed a similar-ish process. The things that I did is basically I started with the video, looking at the video, I the completeness of the idea, whether and the combination of technologies that people use. I looked into the code, the quality of the code and how the code is being done, structured, laid out, and how the components are working. I actually deployed I'll be honest, I didn't deploy all of them that I reviewed, but I deployed at least the top 8 that are there. That we are going to reveal. At least I deployed all of them and then saw tweak some process. Some were excellent. They stand. One component failed, but others was actually still working. How the architecture was flowing and what is the combination. So, and some of the things I'd be honest, I would have done certainly differently, but they have done better than me, on how I'm using. So I'm really amazed on what kind of things that these people build. And I've been. And reminded me of my college days. I used to participate in all kinds of hackathon that I can get my hands on. So it was really amazing to see, and like the completeness of the idea, like everything was working end to end. So I'm really amazed with like all the ideas that I get to see.
I'm just going to say this, and it hurts a little, but in my college days, there was no such thing as a hackathon. I'm just throwing that out there.
I'm not
But
that
if
old,
it were
Eric.
there, it would have done it. That's right. Yeah, I'm what we call a late bloomer. So yeah.
Cool. So, Janek, just slightly on the other side of it, Rajesh just talked about the things that maybe you did people right. What are the kind of things that people maybe missed out on or misunderstood from serverless? Or I mean, there were so many of these things. What did people maybe misconstrue or maybe miss out on? So next time they know what to do.
Yeah, no, I think the quality of the idea for me was one of the big factors, and then obviously architecture and completeness. And completeness, really, I didn't also deploy all of the solutions, but I know like the team did a really good job in making sure that solutions were deployed. So I had confidence there. Like it has to be able to deploy. And then the other thing was, in the video or in the description, some of the developers would write, let's say, 4 end-to-end use cases. But not mention that only one use case of them works. When you try to test the one that maybe does not work, then you sort of left slightly disappointed or with a feeling like, hey, this could have been a little bit more clear. So that clarity of purpose, this one use case or 2 use cases, whatever you have the time to implement, make it like complete. So you're able to demonstrate the value of your solution. You're able to demonstrate the completeness of the solution. You're also able to demonstrate the effectiveness of the idea. And only then you're able to then go into the technical aspects of it, which is the other consideration that is key to most hackathons, not just ours. You're using the right service for the job, and then you figure out the actual learning. Like, hey, I should have used service X and not service Y. I should have used this Graviton instead of x86. I should have used Snapstart. Like all of those things then become clear if you do 1 or 2 use cases end to end rather than focusing on the full solution, which would take obviously months and months to build. I think those were some of the key points I'd like to highlight.
Cool.
If I could add one thing that, and I don't know if we had this in the requirements, but might be a thing to add last time, is folks that really took advantage of the README and the text below their video to introduce the project, be it like inspiration, like where is this idea coming from, but also how it works and the challenges I ran into. Like that really gave us a fuller, maybe more informed understanding of how folks had approached the problem and not sort of like, hey, just here's the solution. But I think it led us in a little bit to the thought process. And I thought that was a really interesting part of the submission content.
Cool. Yeah, and Eddie, I also wanted to ask you, I mean, what surprised you, or what, as you were going through them all, were there things that you were like, oh, wow, or yeah, were there any sort of thoughts of either how people approach them, or even on the actual submissions themselves, or use cases that people came up with, which you were like, wow, cool.
That it's a really well written sort of like story. So it's it's a lot of content. It's like the video is one story, but then also the text content. I guess I was surprised how helpful that was in understanding. And some people took different approaches. It was interesting to see what projects lean into, and maybe that variation was interesting. Some really focused on spending a lot of time on the problem and a shorter time in the solution. Some really led with like, hey, here's my architecture for how I approach this. And so it was interesting to see that variety in people deciding maybe what parts of their projects they most wanted to highlight.
Cool. Is it time? I think we should at least reveal some of
our
honorable mentions. Is that not too early, or should we go to a commercial break, or is that not done?
We can push to tomorrow. Do
a word from our sponsors. Oh wait,
yeah.
Well, let's reveal. How about the winners of our honorable mentions? And honorable mentions is $500 a pop. I can't go to the next slide. $500.
You're correct. Yep.
So there we go. $500 per pop. And the very first one, congratulations to Smart Clip AI. So should we watch the video for Smart Clip AI, and we'll see what that is all about?
Yeah.
I'm just we'll bring it all up.
This is the most challenging and crucial step. The AI analyzes your audience's goal to find the perfect moments and accurately locate the right frames.
Oh, that ended. But yes, so basically Smart Clip AI. Who wants to have a chat about Smart Clip AI? I will put the links in the chats on both kind of things. Yeah, I'll just preface say the video didn't actually do it that much justice, because it takes a long video, splits it up, and uses AI to work out what the most interesting parts are, and then assembles that in another video. Is that a good nutshell?
Yeah, I really like this one. Had it in one of my judging groups early on, and I think the idea is great around this, because we know we create a lot of videos these days. We record long videos with lots of content. So this solution can then break up those into the most relevant pieces, and it's perfect for social media engagement and stuff like that. And I really like the approach of how it was built, using step functions, that it's using transcribe to get the transcription of the content, and then use Bedrock to basically understand what it actually contains, and then break it up into smaller pieces. So I really like this one.
One of the differentiators for this one, I think, for all of us as the judges, was it wasn't just, hey, like, make a clip of the video, but this is shown pretty short, so a lot of folks might have missed it. There's a drop down that sort of had some intention to it, like do a video for educational, for community, for kids. And that was I think that differentiator made this more interesting, that you could do this with intention, not just say like, hey, make it shorter.
Yeah, I've seen a lot of. Go ahead, Eric.
Well, I was going to say, I think that was the differentiator. Yeah, I agree, because there's all kinds of examples where we use serverless to process video, right? Where we can do some GIF creators, things like that. And my first pass this, I was like, oh, it's another video processor. That's kind of cool. But then I was like, oh, hang on a minute. And so it's the video processing is kind of a secondary. That's just like, that's, okay, that's no big deal. It's that intentional look. Pick out the parts of the video that meet a very, using the AI to meet a very specific messaging or things like that. And I thought that was really slick, and that's what highlighted it for me as well. Sorry, Janet, go ahead.
No, I wanted to basically say the same thing in maybe different words with my take on it. But it's very easy to, not easy, but at least I've seen a bunch of solutions that summarize long form documents, or that summarize entire books quickly. But doing that for something like a transcribe for a video, or showing it intent, like, hey, extract the pieces where the mother hands the balloon to the boy and the boy is excited, like those sort of use cases, they're quite unique. At least I haven't come across them before. And that solution, I think, is quite relevant. So the idea was quite neat. The implementation was solid. And I also had this early on in my judging sheet, and I'm glad this made it through.
Sweet.
Cool. Excellent.
Good job.
So next up for another honorable mention. Next up for another honorable mention, we have Buzz CSV. What on earth is Buzz CSV all about? Let's have a look.
Hi, I'm Damien Pace, Solution Architect at Acciona. I'm here to present Buzz CSV and how it can solve issues I've seen in my career where valuable data has been underutilized because it was unable to be processed and users couldn't understand their data quick enough. I've seen it take anywhere from weeks and months to reach a point where an end user was actually able to tell a story with their data. I get approached multiple times a month as a dev in a small dev team in a large enterprise environment to help move off Excel reporting because it hits limitations once the data set reaches a certain point, and it's pretty much the exact same story every single time. So what I'm here today to demonstrate is Buzz CSV, which means a non-technical person could upload a data set and cut that time from weeks and months to actual minutes to query the data and be able to tell a story with that data. So today I'll be demonstrating two parts. So the upload and then the chat function and how you can query it with natural language. So this part here I'll break down and how a CSV gets to S3 and gets to this process here. So what I'll be breaking down is essentially this part where the Parquet actually gets created. I have a producer and a consumer thread. So I didn't want to get into a situation where someone uploads like an 11 gig CSV file and I download it in memory or download it on disk. I didn't want to get into a situation where someone hit limitations and then they have to look for something else. So the producer streams a CSV file in chunks from the S3 bucket and then sends those chunks to a consumer, which then basically writes that to an S3 bucket and then just continually does that until the file has been converted to a Parquet and ready to be queried. So to now break down what I'm doing here in the natural language query assistant, I've asked it how many projects were over their budget utilization that had poor stakeholder engagement in their execution phase. This data set here is a project risk data set. So it lets me know that there's 71 projects. So this is about 10,000 rows. And then if I move on to a data set that has about 10 million, you can see what happens is in the background, it's converting this natural language to an SQL statement based off this schema here. And then I use DuckDB in the background to then execute that generated SQL statement to then get some data. And then I use Bedrock to then make it human presentable, essentially, in the background. Since I don't have quick internet, I just wanted to just demonstrate something on my Lambda logs. You can see here that I'm using less than 3,000 megabytes, and then I'm uploading a 10 million row CSV file in under 33 seconds. So, from the point of upload, within 45 seconds, essentially, you can query your data with natural language. So that's my demonstration of Buzz CSV and how you can cut down processing times from weeks to months to minutes, as you can see. So thank you so much for watching. I hope you enjoyed it.
Okay.
Cool. So Buzz CSV.
Yeah. Let me first say this. Okay, when I first watched this video, because this was early in mine as well, I swear he said, and I apologize, I'm not making fun, but with the accent, I swear he said it was something to help understand your daughters, which I was like, winner, because I have 2 daughters. I don't understand a word they're saying. So I'm like, this is so cool, but it wasn't daughters, it was data, so my bad. So, but this was a super cool project. Gunnar, what'd you think?
Yeah, no, I think this was a super cool one. So such a very specific problem to solve. It was really something that you can tell that he's been through this so many times. He needs a solution for this specific business problem.
Yeah.
And then built a solution for it using serverless. So super cool.
Yeah, no, totally. I was a product manager. I'm a product manager. Deal with Excel and large data sets all the time. And before Lambda, I was in analytics in Athena and EMR, so Parquet formats and large data sets are right up my alley. They cause the opposite of buzz kill, maybe like accelerate the buzz in me. When you see data sets and but like the buzz kill is when the Excel fails to load. So this problem or the solution was really cool, incredible. Highlights the power of serverless and the computing power that you can get and really cutting down the costs here. So,
and also, I mean, this solution was running DuckDB in memory in a Lambda function using a Lambda edit, so it was a good architectural a good way to do it. Also, analytics workloads is all about squashing the data into the Parquet format so that it's super efficient. Stream that from S3, so it is live streaming, the 10,000 or 10 million rows into DuckDB in memory and then spitting it out in seconds. So running this all in Lambda function, and it was 3 gig of memory. It wasn't even 10 gig of memory. So you're running basically a live database in memory in 3 gig, streaming the data in, processing it, spitting it out.
And
cool.
that too in Rust, actually. So
yes,
like this was implemented. Like I first, when I looked at data, I was like, it's okay. Maybe it's like some sort of you chunk the file and load it into but when I went through the implementation, I think you guys pushed me no, this looks like a cool idea. So now I re-ranked it. It's now this is much higher than what I was expecting it to be. So maybe I would have picked a different name, not like a Buzz CSV or whatever, maybe clever CSV, smart CSV, whatever. But yeah, this was really cool idea.
Yeah,
cool. Love it.
Okay, before we go on to the next one, I wait until somebody called it out, but we do need to address this. Yes, Julian cut roughly 12 inches of hair off his head, so just somebody called it out before I did, just saying.
It's a load off my mind, this hackathon.
Oh man.
And this had nothing to do with picking Buzz.
Ooh,
Yeah,
interestingly,
good,
yeah.
project.
nice.
You
Yeah,
see, Addy's on the ball as usual.
there you go. Yeah.
Yeah, slightly different. It was actually strange because I was looking back over years, was doing something else for serverless office hours, and looking back over years. I mean, I think it's like sort of 4-ish years or whatever. And you can sort of see
Yeah.
see the progression of the look. It was looking very different. But anyway,
Yeah.
time for a change. It's all new to do things. Well, thanks, Eric. So now on to the. Now I'm back up to the hackathon. So next up we have Outscan. Excellent. Outscan. So what is Outscan? Let's find out about Outscan.
We all remember that feeling of helplessness as the world shut down, waiting for answers. I certainly do. That feeling is what drove me to build Outscan, my answer to the question, how can we get ahead of the next one? This dashboard isn't just a concept. It's a live look into a system I designed to spot new threats 6 to 8 weeks faster than ever before. Let me show you how it works with a real-world scenario. Imagine a new, unknown sequence is discovered. Right here on the dashboard, I'll select the novel variant sample, which represents a mutation pattern the system has never seen. Now watch what happens. The moment I click Analyze, a fully automated serverless pipeline kicks into gear on AWS. It starts with a secure upload to our S3 data lake. This is where AWS Lambda first comes in. The moment that file lands, an S3 event automatically triggers our first Lambda function, which validates the data and kicks off the entire analysis. From there, AWS Step Functions orchestrates the rest of the workflow. We use other Lambda functions to run specialized tasks. One handles the complex HDBScan clustering to see if this new sequence forms a new group, while another prepares the data for AI analysis. Then, the real magic. We send the new mutation pattern to Amazon Bedrock. The AI analyzes the potential for increased transmissibility and immune escape, giving us a clear risk score. And just like that, the analysis is done. Now look at the dashboard. You'll see the variants detected count just ticked up by 1. And in the prevalence chart, our new variant is now on the map. This all happens in near real time. The reason I chose AWS Lambda is for its incredible scalability and efficiency. Each step you just saw is an independent serverless function. This means my system can run thousands of these analyses in parallel without ever managing a single server. It's what allows us to process data at a global scale for a tiny fraction of the cost of old supercomputing methods. For me, Outscan is more than just code. It's a promise that we can use technology to get ahead of the next threat before it becomes a global crisis. I invite you to explore this live demo for yourself and see the future of pandemic preparedness.
Outscan, congratulations.
Yeah.
So what was cool about Outscan?
I'll say one thing. One thing is like this is not the criteria, but this one had a great hook on that video, and so like kudos for really thinking about the presentation as well as of course the content.
I think the thing that caught my attention up front is obviously real world and real problem. You know, and maybe those mean the same thing, but yeah, this was pointing the power of compute. Actually, a good buddy of mine, he might be watching. Grant, sound off if you're watching. I tried to talk to you about this one, but obviously we had to keep things secret. So I was talking kind of in code, stuff like that. But the architecture being used here is a lot of the same architecture that the Grant's team uses with the Nationwide Children's Hospital when they're discovering cancer, or not discovering cancer, but looking for cancer and doing processing that used to take days, weeks, now is down to seconds because of the kind of architecture that's being done here. So that one, again, pointing this problem at a real world problem or handling a real world problem, and then two, the architecture being used is very powerful. Step functions wrapped around Lambda functions is an incredibly powerful, incredibly scalable architecture. So kudos on this, really well done.
You're really pointing to something there where what I often refer to as the power of serverless, the thing that something like the Nationwide Children's Hospital are using for their cancer research is something that can be used in a hackathon. Same architecture, and they're doing it in a hackathon.
Yeah,
Nothing else than serverless allows you to do that, honestly.
I love that. Yeah, you're right.
And also the code in this example, there's some pretty good code in there because this is doing like sequencing of a huge amount of data in a Lambda function. So the architecture is good, step functions, orchestration, all that kind of thing. But the actual code stuff, looks as though some of this has maybe come out of a research project or something. The coding ideas of something that's been working on for that as well. So yeah, pretty architecture, great use case, and some pretty cool analytics that goes on behind the scenes.
Great job.
Cool, excellent. Next up, we have congratulations to the VA Rating Assistant, varatingassistant.com. Let's hear all about it.
Hi, I'm Chris Lassiter, and I'm excited to introduce you to the VA Rating Assistant, a modern AI-powered web application designed to help veterans quickly estimate their VA disability ratings by simply uploading their medical documents. The VA Rating Assistant was built with Bolt.new using React and TypeScript to deliver a fast, accessible, and responsive front end. Veterans can securely upload their medical files, get an AI-powered disability rating estimate, pre-fill VA forms, and even find nearby VA facilities, all from a single easy-to-use web interface. But what really powers the experience is a fully serverless backend built on AWS Lambda and a suite of cloud-native services. Let's talk about how AWS Lambda makes this all possible. Whether a user uploads a document, it's stored in Amazon S3 using a secure pre-signed URL. That upload event automatically triggers a Lambda function. No servers to manage, just pure event-driven compute. The first Lambda function kicks off the workflow by calling Amazon Text Extract, which extracts text and data from the upload document. Once Text Extract finishes, another Lambda function is triggered. This time, it invokes Amazon Bedrock, which uses advanced AI to analyze the medical text and generate a summary or disability rating estimate. Throughout this entire process, Lambda functions are updating the user's status inside Supabase, our database. And for real-time feedback, we're sending status messages to the front end through API Gateway WebSocket connections, so users know exactly when the results are ready. For large or complex jobs, we use Amazon SQS and SNS to queue and manage asynchronous processing, making sure the system stays fast and reliable even under heavy load. And with AWS X-Ray, every Lambda execution is monitored and traced for reliability and performance. The result is a seamless, scalable, and secure experience for veterans powered by the flexibility of AWS Lambda and the speed of Bolt.new. There's no infrastructure to maintain, and every part of the workflow is event-driven, stateless, and built for the cloud. If you'd like to see it in action, check out varatingassistant.com. We are already working on new features, like tracking conditions over time, adding personalized VA form recommendations, and auto-filling VA forms, and giving veterans more control over their claims journey. If you're a developer, a veteran, or just someone interested in AI, serverless technology, stay tuned. There's a lot more coming soon.
Cool. Congratulations, VA Rating Assistant. I'm going to jump in slightly quickly here because Chris Lassiter, one of the reasons I rated Chris's one very well, other than the architecture, it had great observability story, but Chris was deeply involved in the Slack channel as part of this and was actively getting advice from other people in the hackathon. He was connecting with AWS experts. He was really using the community to help him build stuff. And so he sort of did this in public. And there was a lot of stuff that quite rightly he struggled with because, some of the stuff is super hard. But he literally came out with this amazing app built during the hackathon. And yeah, kudos to be able to, reach out and not just build in isolation. I love that part of the story.
I'll take it a step further. He did get a lot of help from he also helped a lot of the community. I watched a lot of it was really cool to watch the community working back and forth and talking. Oh, did you try this? Did you try this? Even before we could get in there, I actually we had some amazing support. She's not gonna like it that I'm calling her out, but CDS Goat here, she helped. I'm not giving you a real name there, but she was amazing on the Slack channel and helping everybody out. But the community helped each other. But I like this one because of the completion. What we're watching was not a demo so much of the product, but it was a marketing pitch already. The completion of this, and then of course the architecture behind it and the idea that this is a real world problem as well. But I love that. That scored really high with me.
Excellent. Just Cecira is joining us as well as one of our other lovely judges. Thank you very much, Cecira, for quickly seeing, who are you and what do you do at AWS?
Hey, thanks for inviting product manager at Lambda. working on many Lambda features, and excited to see like all the submissions and the winners here.
Cool, excellent. Yeah, so we're just talking about VA Rating Assistant. Anybody else got any thoughts about it?
Just emphasize what Eric said, that just a completionist. What do you say? That it's such.
Yeah.
It is an end-to-end solution that they've been able to build during this hackathon. I'm very impressed by that.
And the observability story was good. He did mention talking about X-ray. I think there was some. I think this was one that also had some CloudWatch dashboards, and had some real stuff though this is an application that could be operated.
Yeah.
Well,
And
did you catch pre-signed URLs? That's the magic right there. A lot of people don't get that, but a pre-signed URL is secure. It's faster than processing Lambda. There it is, right there. I love this.
Yeah. And in fact, one thing I'll add is that the architecture of this is not to denigrate it at all, but it's actually not that complicated, because S3 pre-signed URLs, a Lambda trigger goes off and does some stuff, and then ultimately updates the front end. Architecturally, that's an actual very simple serverless architecture. But it was the completeness of it. It was a great use case, using AI to do some text track kind of thing. Well, in fact, interestingly, it was using text track, so not actually using Gen AI to do that. So that's also, there's a cost implication for that, and then using Gen AI on the back end to generate this thing. So yeah, there's a good way of thinking about it.
Yeah, no, building on Julian's call out, my wife is a doctor, physician, and sometimes the problem of different formats and different readability, that's real, especially in the medical profession. And there's a bunch of tools that doctors are allowed to use and not allowed to use, or they're not as technically proficient as maybe the developer community is. So she's frustrated by this problem, and I've tried to solve it myself, but I couldn't do it very well. So to see someone else leverage Lambda and serverless solutions to solve it was really nice to see.
Cool, excellent. Third prize is for $3,000 Drone Sound Aware. Congratulations to Drone Sound Aware.
Third prize. Well, we got to the.
Hi there,
We just threw that on us.
My name is Ian Brumby. I'm a serverless enthusiast and solutions architect based out of the UK. I'm delighted to introduce you to my AWS Lambda Hackathon project, Drone Sound Aware, working title. A decade ago, we were told about drones. We were promised doorstep deliveries, medical drones delivering aid, armies of these zero-emission drones taking traffic off our roads. It's fair to say that outside of limited trials, we have not yet achieved these dreams. My background is from working with UK Air Traffic Control and the UK regulator. There are significant challenges with regulation here. However, its social acceptance is another key to unlocking large-scale operations. What? Can't hear you. Yes, right. These drones are noisy. Alongside privacy, a lot of the public resistance is going to come from this noise. So how do we get ahead of this minimize noise impact? How can AWS Lambda help us solve these problems in a scalable way? Enter Drone Sound Aware, working title. A solution that allows drone operators to plan, assess, and optimize their flight operations, reducing their noise impact on the community. Okay, so let's get started. I'm going to cover the architecture and use of Lambda first, and then give a quick demo. Here's the basic architecture of the solution. I load gridded population data into DynamoDB on the initial deploy. This is just the UK data purely to keep the deployment times down. I'm using geohashes to partition the data in two different ways to allow efficient queries. There are 3 different Lambda triggers here. Real-time weather data is loaded from an event-bridge scheduled rule. This ensures that drone operations are viable from a weather point of view. We've got Lambdas that are proxied by API gateway. They're there to allow users to populate the map, assess the proposed drone route, and post that route for optimization. And finally, we don't want the front end waiting around for the optimization to happen. Event-driven architecture is our friend here. Use a post to optimize the route. It simply creates a record in the routes table in DynamoDB and returns an ID. Lambda picks up the insert from the DynamoDB stream and performs route optimization based on a variant of the A-star routing algorithm. I really wanted to demonstrate that it's possible to run compute-intensive operations in Lambda here at scale. And of course, we look to follow best practice. It's deployed with CDK. I've used a custom CDK Lambda construct, complete with Power Tools logging, X-ray tracing, and of course deployed on Graviton. Okay, let's go and have a look at it in action. So here's a demo of the front end. The bounding box API calls provide a summary of the high-density population areas and the weather data for displaying on the map context. You can open the operations planner and start to plan your route. Select the start and the end positions, and the route assessment endpoint will determine the impact of this flight. You can see here over 4,000 people could potentially be impacted by this one flight. Click Optimize, and the front end will respond to AppSync. Once the event has been optimized and Lambda has completed and posted its results. As you'd expect, the optimized route is longer, but the population impact is reduced to less than 1,000. Okay, that's it for now. To get started, clone the repo, follow the deployment instructions in the README, and get going. Bye.
Drones, cool.
Yeah.
Well, and Ian, thanks so much for joining us via Twitch. Grateful to be a part of the
Amazing.
Hackathon. Thank you
great,
for your
yeah.
third points.
Yeah.
Good job. Great to have you with us.
Congrats.
So why interesting? Why do we pick this one? Third place is pretty high up.
Yeah.
I think if I can start, like whether it's packages or it's bytes over the wire, delivery is central to Amazon's core, idea of business. It's central to us. And the possibilities of the solution are also endless. Imagine in rural areas where supply chain is maybe not as evolved as maybe in bigger cities. The impact of drone delivery is quite high. So we need efforts and solutions to make it sort of more mainstream than what it is today. It's sort of limited in like use cases today in that sense. On the tech side, I really like the event-driven architecture here. The use case was full end-to-end. Like Ian has taken the effort to figure out Graviton is 34% more price performance, offers more price performance over x86. He's used that, and then he's used Power Tools. Now, Power Tools, I feel personally, is a very severely underrated tool in your serverless toolkit. Especially my favorite feature there is structured logging, which Ian refers to. Allows you to get cold starts and function every size and so all right there in your logs. It's a complete standalone solution. Like I really liked it. Thanks, Ian.
Excellent. Well, thank you very much. Yeah, Janik, that is a great overview. I like it. Any last minute comments from anyone else?
I think this one scored high for completeness too. It was a great, and we see this in a lot of the ones. It's like a really good breakdown of the problem. So in this one, Ian, it looked like you tackled the sound with population and weather. So interesting merge of like more real-time data and static data there, both in like a geospatial space, but could definitely imagine other pieces being added to this, like do like sensitive habitat and pull that in as well. And just all it had, as Janik mentioned, some interesting architectural components, well-defined, and then like a well thought through usable interface to demonstrate.
Cool.
Yeah, I think if I can just add to that, what was interesting for me is Ian comes from an air traffic control background. So it was not like a developer going in and building something unrelated to them. It's like deriving from that real world experience and how serverless made it easy for him to actually build it based on his previous experience.
I love with this idea that this helps thousands and thousands of people out there, and they never know about it. So this has an impact on people that will never even know that they could have been impacted if this wasn't a thing. So I love that.
Yeah. Like I think like similar to Gunnar, like I was not even thinking like this is a thing, right? Like when you're playing with like that, right? Like it's a real world application, which is like actually where like we have not like, or at least I haven't think about like using this in this context. So this was really like that, and then like it was a complete solution working end to end. Where like you can actually hook like an IoT Greengrass device into that drone, and then it can vend the messages into like your SQs or something that like Lambda is very so whole like event driven architecture that could be used to like build and populate that thing on like in like real time. This was really great application. Thanks. Yeah.
Awesome. Number 2 for $4,000, the smart meeting. I was going to say metering star.
I love this one. I love them all. This one's cool.
System.
I like this.
Here's a problem every developer knows too well. You're in a meeting trying to actually listen and contribute, but you're also supposed to be writing down every task assignment for Jira tickets. That's why I built this automated solution using AWS Lambda to handle all the heavy lifting. Here's our front end. Users simply upload meeting recordings and the system automatically processes everything. Behind the scenes, Lambda functions handle the entire workflow. Let me show you how it works by uploading an actual meeting recording and walking through how AWS Lambda orchestrates the entire process.
Hi everyone, so we're finally kicking off the serverless notification system. We've got 3 main Lambda functions to build, and Mike, I'm thinking you take the authentication Lambda. JWT validation, cognitive integration, all that fun stuff. Can you have it ready by Friday? Yeah, totally. I've been wanting to dig deeper into Cognito anyways. And then it's perfect. And Alex, how do you feel about handling the infrastructure Lambda? It'll auto provision our DynamoDB tables and set up the API gateway route. Sounds good, yeah. That's right up my alley. Thursday deadline work for you? Absolutely. James, you quit building the notification Lambda. Basically, SES email delivery stuff. Sure thing. Fair warning, I might get pulled into other fires this week. So, no worries, we'll figure it out. What do you say? Let's take him out Wednesday. Yeah, that sounds good. Yeah, sounds good. Okay, then see you then.
Let me show you the results in our Jira tasks section. The system successfully extracted 3 actionable tasks from that meeting recording, and clicking any task takes you directly to the corresponding Jira board for full details. Now I'll upload our follow-up meeting to demonstrate how the...
I'm just going to pause here because we go just for the series of time, because these videos are absolutely incredible having the 4 people in the meeting. But I think you're sort of going to get the idea, so we're going to
you can
just
see
show
the intelligent updates in action. Task statuses have automatically changed to reflect progress. Assignee information has been updated based on discussion, and the system even created one completely new task that emerged from the conversation. To showcase the full capabilities, I'll now upload our final meeting recording.
Final Friday check. Alex.
Okay, another meeting request, which is awesome. The 4 people are going to go through all the kind of stuff. We will pick up.
See the completed workflow. Tasks that were marked as finished during the discussion now show done status in Jira, demonstrating end-to-end persistence and fetching existing Jira tasks. Everything goes through API gateway to the Lambda functions. When a file hits S3, Event Bridge orchestrates the entire pipeline automatically. First, audio gets processed and stored in DynamoDB. Then Amazon Transcribe converts speech to text. Next, our AI processing extracts actionable tasks using Amazon Bedrock's Cloud AI. Finally, our Jira integration services use AI to decide whether to create new tickets or update existing ones. The system connects to external Jira Cloud through secure API calls with credentials managed by AWS Secrets Manager.
Oops. Sorry about that. Yeah. A meeting planner. Meetings takes the recordings in, finds all the actions, spits it off the Jira. We need this everywhere, don't we?
Yeah. That was
problem. Go ahead, Eric.
Well, that was the attraction to me. It was like this hits so close to home. It's like, oh my gosh, I need this. And so that caught my attention first, but then the architecture also got me. And then I thought the videos were hysterical. I don't know if you were going for comedy, but that was gold. So,
yeah, I mean, this problem has existed, I think, ever since humanity started. Maybe, obviously, I'm not as old, but like this note-taking, assigning tasks, and it's still growing. You see companies like Asana and Jira, and like Atlassian, like doing this is central to their business. We've used handcrafted notebooks and fine-smelling papers and chalks and slates and a whole bunch of tools, but this one was quite a unique solution in that sense. The other part I wanted to highlight about this was, it uses the power of event-driven architectures. The developer especially calls out in the challenges they had to overcome in learning EDAs, as we call them. It really magnifies the services and the breadth of AWS that has to offer. Lambda is central to obviously event-driven architectures. There's a function to put events in Jira. There's a function to, upload securely to S3. There's a function another to, do this transcribing and so on. Just fully complete end-to-end solution with the Jira integration there. Really well done.
Okay.
Absolutely. Yeah.
We got to jump. Yeah.
Love it. A winner. Congratulations to Forest Shield. Round of applause, everybody. $6,000. Let's hear all about Forest. Let's hear about Forest Shield.
Deforestation is one of the most urgent environmental challenges we face. But detecting it in real time is hard. Satellite data is massive, analysis is slow, and most systems aren't scalable. That's why I built Forest Shield. a fully serverless ML-powered platform for monitoring deforestation using AWS. We'll start by creating a new region to monitor over Colombia. We drag from the center to the radius of the region we want to cover, with a set maximum of 50 kilometers. Next, I subscribe to alerts using AWS SNS. Now let's trigger the analysis. I send a request to the API with that new region. As soon as the request is received, it kicks off a step functions workflow. This is the core orchestration engine that stitches together everything. It begins with a SnapStart-enabled Java Lambda that queries the Sentinel-2 Stats API for imagery, which is served through S3 buckets. This optimization makes image retrieval lightning fast, so that each satellite image is then processed by parallel Python lambdas that calculate NDVI, the normalized difference vegetation index, from the red and near-infrared spectral bands. Every pixel becomes a 5-dimensional vector capturing NDVI, reflectance, and geographic data. These vectors are passed to Amazon's SageMaker, where we perform k-means clustering to classify land cover types. A separate Lambda function determines the optimal number of clusters using the elbow method, and we reuse existing models when possible to reduce compute costs. Once clustering completes, results are visualized and consolidated. The final Lambda generates a detailed PDF report and pushes an alert through SNS. Let's open the email. We can see a high-priority deforestation alert. The attached PDF includes summary statistics, vegetation loss, NDVI trends, and a confidence score, all automatically generated. Back in the dashboard, we can trigger that same Lambda for searching images, but in isolation, so that we can manually view the satellite images that are being scanned over the chosen timeline. It's showing us the cloud coverage across the chosen time range, and in each we can see the satellite image in addition to the NDVI calculation results. We can view the scatter plots, red band distributions, and clustering results from the SageMaker job. These graphs are generated serverlessly and pulled from S3 via signed URLs, and the dashboard itself is live and reactive. Powered by a real-time WebSocket gateway, alerts appear the moment they're triggered, and we use the same infrastructure to stream CloudWatch logs for instant visibility into Lambda execution. But Forest Shield isn't just a tool for one-time analysis. It's a system that learns over time. Each time a region is processed, the clustering models adapt, refining their understanding of local vegetation dynamics. We reuse and evolve these models to reduce compute costs and improve accuracy with each run. Over time, these insights form a growing data set of land cover patterns, vegetation loss, and deforestation events. That historical intelligence can power predictive models, helping scientists forecast deforestation risk, study the impact of restoration efforts, or correlate land degradation with climate and policy data. That's Forest Shield, everyone, turning satellite data into real-time forest intelligence.
Congratulations, Forest Wave. So, why is this the winner, everybody?
Many things. Overall completeness, interesting problem, interesting approach and use of architecture. They kind of nailed it on, I think, most counts.
Yeah, don't go treeless with serverless, right? Like, I couldn't try to fit these things, but like this was overall a great application of like how serverless tools to be used, like how you can like have different like step functions and like event-driven architecture, Lambda, and like how do you synthesize data together, and like how this shows that like for a lot of like analytics use cases that we don't think, like we sometimes have this bias in our head. It's like Lambda is not suitable for this, but like what I have seen or like what I realized that's like a lot of analytics use cases that I don't see like people using Lambda was being used, and these like real world integration with like AI tools, with like what is available in like our power tools, what our libraries are available. This was like really great end-to-end application. This was really amazing. Congrats to the winner.
The satellite data sets are obviously massive, they're huge, and it needs a lot of lambdas in parallel to process, which we're able to give, very rapidly, very fast. There's also this unique technology called SnapStart. It helps to speed up the cold start or, the initialization time of your function. And the solution leverages that to improve latency, increase more real-timeness, which was really nice to see. Really well done.
And there was some hardcore
That's-
mathematics running in some of those Lambda functions as well. I mean, there was the elbow model or something. I had to look that up. I've already forgotten. But yes, those Lambda functions do some hardcore mathematics, connecting to SageMaker, connecting a whole bunch together. A wow UI, awesome. Love it.
I think for this one, the documentation is very extensive as well. It really describes clearly the problem and how they're solving it. So that was very helpful for us as judges to really see how complete the solution is and all the data that's behind it to actually build this sort of solution.
Yeah, this was obviously a project of passion that someone applied serverless to. They didn't come up with that in 1 month, but the serverless architecture they did, and it was really impressive. Real world problem, crazy good architecture, good completion, good documentation, all the things. I thought this was absolutely amazing. The analysis that was going, I didn't understand most of it from a scientific side to look some of it up as well, but the analysis that was going on is amazing. So very cool project.
Yeah, everybody, thanks so much. This was absolutely awesome. Eric posted in the chat as well, but there is a new link, s12v.com hack-lambda-winners. This has, maybe even has that already, has all the winners up over there, has all the information. Yeah, I mean, we had thousands of people do the hackathon. Thank you to thousands of people for doing this. We had hundreds of people submit kind of things. We've got our final 3 winners and our 4 honorable mentions. So yeah, appreciate from the bottom of our hearts, everyone putting their heart and soul into building some cool stuff for Lambda. These were just the highlights. I promise you the numbers of the other ones we looked at, there were still some amazing ones as well. So if you didn't make the winners roster, please feel at least proud and impressed that you at least put something together. Judges, most of all, thank you very much for your time as well. It was fun. It was entertaining. It was inspirational. Nick Holt, who's one of our sort of chief of product as well, isn't on the call today, but he said this was also an amazing learning opportunity for us in Lambda to see what people build. I mean, this is open to the world to build anything. So they're great learnings. Anybody have any final words or anything you'd like to wrap up on?
I'll throw this out real quick. If you're looking for another hackathon to do, then I'll pass it on. If you're looking for another hackathon to do, look at the Kiro hackathon. So you can check it out here, Kiro.dev blog code with Kiro hackathon. And I just want to say thank you. Really amazing. Addie, I'll turn it over to you.
Just seconding it, really cool. It was hard to whittle all of the selections down to this set. Awesome to see all the things that people are doing. We saw a lot coming in with event-driven solutions for leveraging Bedrock, and that was really interesting. Like if we did this 4 years ago, it would have been a very different set of things.
And it was a really humbling experience, like a very privilege to be able to see some of these solutions in action. Very energizing for us as the service team members to be able to work on a product that can add so much meaning and value to lives. So thank you so much for participating. Really appreciate it.
I want to add one thing on the Bedrock piece is I was kind of expecting people to go all in on Bedrock, but what really struck me as very good thing is that people chose the very specific services where they could easily have thrown everything to Bedrock, but instead they went with TextTrack, they went with Transcribe, those kind of services that have a specific purpose. Use those and then put in generative AI where it's actually needed. So purposefully selecting services is great.
I'm going to call it there. We need to wrap from our producer. But yeah, I agree with that. So thank you all for joining us. Same time next week, Julian?
Same time, same place. Eric is going to be hosting next week. We're going to be talking API gateway security, I think. Yeah, I think that's the right one. But yeah, same time. Thanks to everybody for the hackathon people. Thanks for all the judges. Peace out from Serverless Office Hours. Goodbye.
Bye.